Hello, welcome to the CS445 Team 7 video. This is Ameya Deshpande, and I built the robot along with Jasmine and Juan-Luis Vasquez. So, our robot's point was a mission to the cure. And a mission to the cure means find two viruses and put them back in the respective labs, as you can see on the map right now. We spent a lot of time putting work into this robot. Let's talk about it. Alrighty, so we faced more than our fair share of problems during the construction of the robot. Here you can see the robot, its sensors, everything is detached right now. We spent a lot of time tightening the wheels, mostly so that the wheel there'd be as little slip as possible when the servo motors would move, and that really helped us in our PID. So here's our finished robot. Um, we had a couple of unseen problems. For one, we were powering it with only one of the battery ports for a while, and the reason that kind of messed things up is because it wasn't feeding the robot. It was feeding the servo motor's power through the Pi, and that would mess everything up. So we figured out that, hey, like, it was the servo motor that was being powerless, and it was like messing up all the time, so we had to like reconfigure all our powering, and that gave us a really fast thing. So right now here's our wall following, and this was kind of the building block on our PID for the final project. And this was really hard to do. It took a long time, but once it worked for like extremely well. And this is what carried us through to finish the project with 100% of the tasks completed. So yeah, the PID pretty much works in the way that if the robot it uses a sonar to see if it's more than 30 centimeters away from the robot, or more than five or less than 5 centimeters close to the wall. I'm sorry, 30 centimeters away from the wall. So basically, what it does, if it's too far away, it moves out. If it's too close, it moves in. Therefore, it'll kind of stay in a straight-ish positioning, which is really important when it came to navigating through the walls. So our course was the course for the entire class. It was the maze, and then there was the two locations of the viruses and the two labs at the bottom. We used a red virus, which was a crudely built Lego brick. It was just a sheet of red, and we also had a blue virus, which is also a crudely built Lego brick. Our robot could sense red and blue the easiest. So here we had on-screen robot tracking, and that just told us where the robot thought it was, and if the robot was seeing everything properly. So here's our final run. Needless to say, it was pretty darn epic. So the robot's about to start soon. So as you can see, it looked one way, it looks both ways. Sometimes, depending on how far it is from the walls, it'll adjust. As you can see, it adjusted left a little bit. That's just to keep it straight. And most of our navigation was done through a pre-programmed A-star algorithm, so it was kind of A-star on rails. And this was because there were only a finite number of combinations that the robot could do, so we had programmed all of those in. Therefore, it wasn't too hard. The robot kind of just does things based on where it thinks it is, and it moves a certain amount of steps each time, so there's a minimal amount of error there. So it's going to locate the red virus now. So that 180 turn that it just did looks easy, but it was quite a bit difficult actually. The reason is that based on where the virus could have been, it would have had to move different ways to properly use the PID to be able to navigate. And we basically just included a bunch of if switches. So based on the robot, where the robot thinks it is, it would have moved a lot of different ways. That was pretty much the gist of how we designed the entire navigation system. Since we didn't have a compass, we couldn't do anything dynamically. We had to do everything iteratively, and we had to have a bunch of cases. It did take a long time, but it actually ended up creating quite a reliable system in a way, because we could always know what the it was easy to figure out what errors were going on, and most of the time solving those errors just meant doing a little bit of uh, adjusting the code, adding a couple if statements, and so forth. So here we have the robot doing one of its more sketchy turns, and although this did scare us a little bit, what kept us going, what kind of assured us was that the robot was moving towards the farther wall, and this really helped it like move to where it should be to keep straight. So here we have the robot at the goal, and it still turns on its camera, and it'll just recognize the brown wall and realize that that's the goal wall, and then it'll keep going. So we had that programmed in just so it would identify where the goals were. So this was the last case, so it did take a long time for it to determine if it was at the lab, because it would first check if it was at red, then at blue, and then the lab. So it's moving out here. So now it'll look for the virus in the topmost right position on the map, and here it is doing that. And once again, it's, oh wow, it's a little close, isn't it? Yeah, that's the only problem, that if it were to catch on one of those things, we would have to have it move out a little bit more, and that would probably make it run way longer. But anyway, here it is, and it's at where a virus could have been, and it's looking for it right now. So it looks back, so it's at the optimal position. And it's looking for a long time. It's looking if there's a red. Now it's going to search if there's a blue, and then it's going to search if there's a tan. But this is a white wall, and there's nothing on that white wall. So it's going to wait, and turn again. So now we're heading towards one of the other places, which is the blue, and blue can only be in one location, so it knows that if red isn't there, then blue has to be there. So here we have the robot moving towards the blue virus again, and this is the final check that it'll do. It'll still see if the color blue still matches up, just in case there were any virus swap ups that could have messed with its internal map. And once again, the reason that the robot is checking both ways with the sonar is that to see which wall it's farthest away from, because it always wants to center itself, because it always wants to be on the path that it's programmed in. So here we have it approaching blue virus. Very exciting. So that's that, and we're moving on to, we're on the last leg here, we're going to move on to the final lab. And once we're in the lab, all it'll do is see if there's a tan brick there, or a tan wall, and it'll immediately stop because it's done its duty. It has saved the world and has retrieved the viruses and moved them back to the labs. So now we're at the very last leg, and it's a little off center, so when it turns, it's going to move a little bit to the right. So here we have it, and we're at the blue. Woo! Yay! Everybody's happy. This was pretty hard, took quite a bit of time, but it was worth it. So now I have some credits. I would like to thank everyone involved with CS445, including, especially Professor Ayanian, for checking out lab, and Joseph, especially for giving us all the help we needed. Thank you, Joseph. You're the best. Goodbye.